Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra I class. We are today going to talk about solving linear inequalities. Linear inequalities. I know that some of you are thinking, oh, well, we already did inequalities. Yes, we did. We did straight up inequalities. What we've done already is stuff like this. 2x plus 5 is less than or equal to 7. Subtract 5 to both sides. I got 2x is less than or equal to 2. Divide by 2. X is less than or equal to 1. Then we had my 0. We had my 1. It's less than or equal to, so it's a closed circle shaded to the left. That's just an inequality. What's the difference between an inequality and a linear inequality, my friends? The y. Okay? Once you put a y in there, you're going to have a linear inequality. Remember, whenever they're talking about linear, you're talking about a linear equation, which is y equals mx plus b, or a linear inequality, y is less than or equal to mx plus b. Now, of course, that could be less than or equal to, or greater than or equal to, or less than, or greater than. Okay? And we'll talk about all of those today. But when we're talking about a linear equation or a linear inequality, we're talking about an x and y axis. When working with linear equations, every single ordered pair directly on the line is a solution of that equation. We've been talking about this and working with linear equations for a while now. Consider examine the graph of the equation y equals negative 3x minus 2. Sorry. Y equals 3x minus 2. My y-intercept is negative 2. That's my b. My slope is 3 over 1. So I go up 1, 2, 3, 1 to the right, 1, 2, 3, 1 to the right. I can go backwards from the y-intercept, down 1, 2, 3, 1 to the left. I connect my ordered pairs. And I have my linear equation. No worries. Nice and easy. Today, we're going to work with linear inequalities, like I said. And we're going to replace the equals with one of these guys. A greater than or equal to, a less than or equal to, a less than, or a greater than. Okay? That's what we're going to do today. Now, when solving linear inequalities by graphing, there will be an infinite amount of solutions. So you must shade your solution set or zone based on the boundary. When you're going to graph linear inequalities, you're going to graph them exactly the same way as graphing a linear equation, except let's notice a few things. Notice how if I have a greater than or a less than, I have a dashed line. A dashed line. So when you have a y is greater than or a y is less than, you're going to graph using a dashed line because points on that line are not solutions. So what are the solutions, Mr. Morrow? Well, look at what I just set up for you here. If this is my line, and it's a y is greater than x, greater than, you're going to shade above the line. Always find the y-intercept. The y-intercept is right here in this case. If it's greater than, you're going to shade above. So you're going to literally shade above the line. Does that make sense? If it is a y is less than, look at the y-intercept again, and you're going to shade below the line or below the y-intercept. So you're going to shade below the line when it's less than. Does that make sense so far? Okay. Now let's say the slope is negative. How do I know it's negative? Because I'm pointing down from left to right. Here's a negative. That's my slope, right? Okay. If I have a negative line and I go y is greater than, I still am going to shade above. Look at my y-intercept, above, shade above. So I shade above. Notice that it's greater than, so again it's a dashed line. If I have an y is less than negative x, I'm going to shade below the line. So again, the easiest way, find the y-intercept, shade below that line. Okay? Nice and easy. Same exact shading procedure, but now, if you notice, if I have a greater than or equal to, or a less than or equal to, I have a solid line. So when I have a less than or equal to, or a greater than or equal to, I'm talking about a solid line. Not a dashed line, but a solid line. Same shading though. If I have a y is greater than or equal to x, I'm going to shade above the line. Above the line. Find the y-intercept, shade above it. Okay? If I have a y is less than or equal to x, I'm going to shade below it. Find the y-intercept and shade below it. Okay? If I have a y is greater than or equal to negative x, I have a negative slope. I want to shade above it when it's greater than. So I shade above the line. If I want to shade below the line, it's because it's a less than or equal to. I'm going to shade below the line. Gentlemen, do you see what I mean here? Okay. So if you know how to graph an equation, a linear equation, then you know how to graph a linear inequality. The only difference is if I have a less than or greater than, I'm going to use a dashed line. If I have a less than or equal to or a greater than or equal to, I'm going to use a solid line. And then I have to shade. If I have a y is greater than, I shade above the y-intercept, above the line. If I have a y is less than, I'm going to shade below the y-intercept, below the line. So now that we've got all that out of the way, now it's Mickey Mouse time. Y is greater than or equal to 2x minus 3. What is the graph of this linear inequality? What is the y-intercept, please? Excellent. So I go down 1, 2, negative 3. Awesome. What is the slope? So I'm going to go up 1, 2 over 1 to the right, up 1, 2 over 1 to the right, up 1, 2 over 1 to the right. Let's go backwards. Go back to my y-intercept, down 1, 2 over 1 to the left, down 1, 2 over 1 to the left. Is this going to be a solid or dashed line? Solid because it's greater than or equal to. Now, am I going to shade above or below? Above. Here's my y-intercept, so I'm going to shade above. Guys, notice how I do these straight lines? Later on, when we're doing systems of linear inequalities, like in the next section or two, we're going to have two lines that are shaded at the same time. So I need you to make straight lines so that later on, don't write this down, but later on, let's say when it's like this, do you see where I have my checkerboard? That's going to be the solution of both equations. You feel me? So please be neat. Do not, I repeat, do not do this. Because that's just going to be really difficult for you later on. Okay? I promise. So just two nice straight little lines that indicates to me that's the shading. Does that make sense, gentlemen? Awesome. Thank you. Okay. As always, we're going to have word problems. And when we have word problems with inequalities, there's some words that kind of mess you up sometimes, okay? Please pay attention. If I tell you, and this is wrong, this is wrong. John is, yeah, this is wrong. Has to be is at most. So it says is at most, that is less than or equal to. I like to look at age for this. It's always helped me out. If I told you guys are at most 16 years old, what does that mean to you? You're at most 16. There you go. That you can be 16 or younger. So that's why at most means less than or equal to. What happens if I tell you you guys are at least 14? So that means you're 14 or older. So that's greater than or equal to. At most, it's kind of like reversed. At most is less than or equal to. At least is greater than or equal to. Okay? If I tell you is less than, is the big key. Let me explain why that's such a big key. Guys, if I just tell you this, x less than 5, how do you write x less than 5? 5 minus x. Thank you so much. But if I tell you guys x is less than 5, how would you write that? X is less than 5. The is indicates equality. The is indicates equality. The is indicates that it's an inequality. So if it's is less than, it's just a less than symbol. If I tell you is more than, it's a greater than symbol. Again, why is that so important? Why is he making such a big deal? What if I tell you 5 more than x? What is that? 5 plus x or x plus 5. But if I tell you 5 is more than x, 5 is greater than x. You guys with me there? Okay, thank you. Now, let's just graph. X is greater than or equal to negative 2. What kind of a line is an x equals line? It has an undefined slope, so it's a vertical line. So I go to the negative 2. Am I going to be dashed or solid in this case? Solid. Now, you can't shade above, but you can shade to the right in this case. Thank you. Because x is greater than. Guess what? You're done. That's it. That's your graph. Done. Y is less than or equal to 2x minus 3. What's my y-intercept, please? Negative 3. What's my slope, please? Up 1, 2 over 1. Up 1, 2 over 1. Up 1, 2 over 1. Go backwards. Down 1, 2 over 1. Down 1, 2 over 1. Solid or dashed line? Solid. Shade above or below? Y is less than. You always read from the Y. Y is less than, so you go below. Does that make sense, my brothers? Okay. Y is less than or equal to 3. Actually, you know what? Wait. Let's do something. We're doing too many less thans. I don't like it. 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 All right. Let's do some, different, okay? Some different stuff. Okay. Thank you, guys. Now, y is less than 3. What is that going to be? Horizontal line on the 3. Is it going to be dashed or solid, my men? Dashed. Please make a note of that on your notes, guys. You can't erase like I just did. So just kind of scribble it out, please, or scratch it out and put just less than, please. I don't want you to get confused when you're studying. So exactly what my boy said, 1, 2, 3, dashed. It's less than, so am I going to shade above or below in this case? Below. Very good. So what does this mean? That means that every single value in here will make this true. That's what the shading means. Every single value here will make this true. And I'll prove it. Let's check 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 6, negative 4. If I'm right, that has to be a solution. Let's check it out. Is negative 4 less than or equal to 2 times 6 is 12 minus 3. Is negative 4 less than or equal to 9? Yes. And any point you choose within this solution set, and that goes on for infinity, that will make the equation true. You guys with me? You understand the concept here, right, my brothers? Awesome. Thank you. Okay, now we get to the stuff that I know a lot of you don't like, but that's life. What do I have to do here for D first? Thank you very much, my friends. You have to get the y alone. Excellent job. Subtract 2x to both sides. Negative 3y is greater than negative 2x minus 3. Excellent, son. Divide by negative 3. But what happens to the inequality when you divide? You flip the inequality. Thank you. Remember that this negative 3 divides to here and to there. So this is going to be 2/3 x, because a negative 2 divided by a negative 3, the negatives cancel. And then negative 3 divided by negative 3, thank you very much, plus 1. Awesome. Now let's graph it. What's my y-intercept, please? 1. What's my slope, please? Up 1, 2 over 1, 2, 3 to the right. Up 1, 2 over 1, 2, 3 to the right. Go back to the y-intercept. Down 1, 2 over 1, 2, 3 to the left. Down 1, 2 over 1, 2, 3 to the left. Go ahead and connect the dots. I didn't ask the right question. Thank you. It's dashed, Mr. Morrow. Pay attention. Thank you. And you're going to shade down, my man, because y is less than. Hey, I just made a mistake too. We're all human. Thank you for caring, though. You're going to shade below because it's y is less than. And again, don't make it messy. Make it neat. Great job, son. Great job. Does that make sense, my boys? Okay. May I continue? Thank you. Okay, now, sometimes I'll tell you, find the equation for each graph. And actually, technically, this should say, find the inequality. That technically should say, find the inequality. So, okay, remember, guys, this is a linear inequality. So you have a y equals mx plus b. So you got to find an m, your slope, and you got to find a b. And then you got to tell how it's shaded. So what is my y-intercept here? 1, 2, 3, 4. Wait, 1, 2, 3, 4. That's okay. It could be hard to see from the seat. So that's 4. What is my slope? I'm going from this perfect point to this perfect point. Negative 1, down 1, over 1, 2, 3. So my slope is negative 1/3. Now, is this shaded above or below the line? So is that going to be a greater than or less than? Is it dashed or solid? So it's going to be y is greater than negative 1/3 x plus 4. Fantastic. Yes. If it was solid, then it would be greater than or equal to, right, guys? Yes. But it's not. So it's just greater than. Not too bad, right? Okay. Find this equation or inequality. Okay. Find the slope, find the y-intercept. What's the y-intercept? Negative 2, yes, show it to yourself. So from this, yeah, a perfect, not really, no, here, wait a second, no. Here's another perfect point. Here's another perfect point. So hold on. 1, 2, 3, 4, 5 over 1, 2, 3, 4. Yeah, my slope is 5/4. Because I go 1, 2, 3, 4, 5, 1, 2, 3, 4. Yeah, 5/4, my friends. Remember, you guys are in your seats. It could be a little bit tough for you to see. I'm right here in front of it. But look at your notes though. You have your PDF notes, they're right there in front of you. But I promise you, it's up 1, 2, 3, 4, 5 over 1, 2, 3, 4. Really close to 1 over 1, but it didn't make the cut. Okay, so what kind of inequality is this? It's shaded below and it's dashed. Less than. So y is less than 5/4 x minus 2. And remember, you should be saying to yourself, wait a second, this is perfect. The slope is positive. My line is going up from left to right, so that is correct. You could always see if you messed up with your slope. Sir?
Are we ever going to get a line that's not...
Are you ever going to get a line that's not dashed?
Like a solution that doesn't work, and then we have to find out whether it's...
Okay, you're going to get a line that doesn't have a solution and then make you... No, that doesn't make sense. But thank you for asking and caring. Okay, now, the fun part. For a party, you can spend no more than $12 on nuts. Peanuts cost $2 per pound. Cashews cost $4 per pound. What are 3 possible combinations of peanuts and cashews that you can buy? Thank you. First of all, you can. You absolutely can and should label. X is going to be peanuts. Y we're going to call cashews. Now, they didn't mention any quantity here, right? They mentioned value, correct? Cost, right? They said it's $2 per peanut X plus $4 per peanut for cashews Y. But you can spend no more than, thank you, say it out loud and proud, less than or equal to. This total has to be less than or equal to $12 because it's no more than 12. Does that make sense?
Yes.
Now, let's see who has really learned about equations here. What's the best, easiest, quickest way to graph this bad boy right now? Yes, sir. Thank you. Thank you and thank you. We're going to use the x and y intercepts. For those of you who don't want to use the x and y intercepts, it's going to take you some time to solve for y. I'll do it for you, but let's first do it the right way. First of all, hopefully you realize that you could do it by intercepts because both 2 and 4 are factors of 12. So therefore, if you remember, my x-intercept is the x value when y is 0. So if I get rid of this for a second, it's 6, 0, right? And then, actually I shouldn't have done that. So that's 0, I got 6, 0. My y-intercept is the y value when x is 0. So you get rid of this, right? So it's going to be 0, 3. So check this out. Boom. And then 1, 2, 3, 4, 5, 6. Boom. Is it going to be dashed or solid? Solid. Am I going to shade above or below? Below. Why am I not going into the negative region? That's right. You can have negative peanuts or cashews. Now, guess what, guys? Anything inside of here is a possible solution. Anything inside of here. And along the line, because it's solid. Anything in there is a possible solution. And I mean anything inside of that region is a possible solution. Yes, sir. Well, yeah, if you have 3.2, 5.7, yeah, but any whole values are going to be solutions. For example, let's say this point right here. That's 1, 2, 2, 1. Let's see if that works. Let's see if that works. If x is 2, that's 4, plus 4 times 1 is 4. Is that less than 12? It works. It works. Does this make sense, my friends? Awesome. I think we're good. Thank you very much. I hope you learned a lot and have a great day.